Okay, we're going to finish chapter 7, which covers arrays. And we're starting in the middle of section 7-5. Slide 43. Share my screen. Desktop. So this is an example of finding the total and finding the average in an array. It's just going to be just like we were doing where we found the total, the sum of a set of inputs, except this time we're going to get the total from the array. So here we have the array scores. We're going to iterate through each item and scores and accumulate the value and then average the total. So average equals total divided by num scores. Num scores is just going to be a constant. So let's say that this array had 5 scores, then you would divide the total by 5. This is an example of what we do if we need to look to find the highest value of an array. And so here we're using just a regular for loop starting at 1 and less than the size of the array, count plus plus. So the reason we're starting at 1 is because we're setting the very first element of the array. We're going to make that the highest. We're going to say, okay, the first one is the highest. You got to have a starting point. Then what you do is you compare that first one to the second one, and you say, if the first one is less than the second one, then the second one is the highest. And you go on to the next one, the next one, the next one. So here, this is the second one right here. So this is number sub 1. This is number sub 0. So you're saying if number sub 1, if the second one, it's bigger than the first one, then we're going to switch. Who's bigger? Bigger is the second one. And so let me see. Lowest, you just do less than. So this is actually really important code because this is one way that we can sort an array, or this is you know, if you have a program where you have 10 test scores and you want to drop the lowest, you know, you have some teachers that drop the lowest quiz score, the lowest test score, then this could be one way that you do that. And so you just want to make sure that you understand what is going on here. Sorry, got to make my phone on do not disturb. Just 1 second. Okay. So make sure that you run this and that you look at it. Give you an example. So let's say I have 10. I'm going to have an array of 3 things. So this is going to be, the array is called numbers. So this will be number sub 0, number sub 1, number sub 2. And so the first time number sub 0 is 10. So lowest is 10. Numbers sub 1, count as 1 the first time, is a 5. Okay, and it says, is 5 less than 10? It is. So now lowest becomes number subcount. Number subcount, this is a 1, right? Number sub 1. So lowest is 5. So now that lowest is 5, this is the lowest. Now we go back up to this loop, count now becomes a 2. And number sub 2 is a 20. So this is a 20 now. And the lowest is no longer 10, it's a 5. And we say, is 20 less than 5? It is not less than 5. So we go back up to the top. The size of the array was 2. So our loop is going to stop. Let me solve this. So it would be good for you to, you could see out to see what's going on here, see out lowest, and you could see every time this lowest changes. Partially filled arrays. If it is unknown how much data, let's see how I can get rid of this. Okay, so if it is unknown how much data an array will be holding, make the array large enough to hold the largest expected number of elements. So for example, let's say that you're asking somebody for well, let's say that it's a program and it's going to get grades, right? And depending on the teacher that uses it, one teacher might have 10 grades, one teacher might have 20 grades to average, one teacher might have 30 grades. So you want to make the array as big as you think, you could possibly have the number of grades. And so let's say we could make the array 1,000 elements. And if we make the array 1,000 elements and we only use 10, that's okay. But you don't want to make the array 20 elements and then have somebody who has 50 grades, because then the program is not going to run properly. It's going to at some point it's going to break. So better to have more space that's not used. Comparing arrays. So this is an example of how to compare arrays. So here, arrays equal. Okay, so this program, what it's doing, if the arrays are exactly the same, if they're equal, then it's going to, if arrays are equal, it's going to print the arrays are equal. It's going to do this. If any of these numbers do not match, then it prints the arrays are not equal. So right now the arrays are equal, all the numbers match. So it would print this first line. So how does it do that? So the first thing you want to do is you want to set a Boolean. The Boolean, you're going to set it to true. So you're going to start with, yes, all the arrays, both arrays are going to be equal. And you change it to false if one of these numbers do not match. Now we're going to go through the whole array with a while loop. If the arrays are equal, so only go through the while loop if they keep being equal. The second you find one of these numbers that's not equal, then stop the loop. And count is less than size. So you're going, size of the array is 5. So you have 1, 2, 3, 4, 5. Count counts how many times you've gone around the loop. So when while count is less than 5, you're going to keep iterating and checking. Count's going to start at 0. Why does it start at 0? Because this is element 0. This is element 1. So this is first array sub 0 holds a 5. First array sub 1 holds a 10, etc. So we compare. We just go through and compare. Is first array sub 0 not equal to second array sub 0? Well, they are equal. So we increase count. It changes to a 1. They're still equal. Count is less than size. Is first array sub 1 not equal to second array sub 1? They are equal. If they were not equal, let's say that this was an 11, then it would set this to false. This would be false. The array would exit, and the if would then execute, and so we would say, is it true? No, it's false, so they're not equal. Okay, let's see if I can erase everything. Okay. Using parallel arrays. So parallel arrays are, let's say that you're keeping track of student data, and you have an array that holds 10 student names, so 10 strings. And then you have an array that holds the average for each of those students. So you have Mark is student sub 0. Mark's final grade is grade sub 0. So whatever is an element sub 0 corresponds to the second array's element sub 0. So the data is related. And the subscript is what we're using to relate the data. The arrays can be of different data types. I can have a string and a float. So here is an example. I'm going to show you, I'm going to go ahead and do an example for us. But before I do that example, this is employee 1. Employee 1's hours are 10. He gets paid $9.75. Employee 2, his hours are 15. He gets paid $8.62. So these are parallel. These hours correspond with this guy's pay rate or girl's pay rate, okay, or person's pay rate. Okay, so if I'm going to go to CPP, okay, so here we have main, and I'm going to make an array of strings. So string now I'm going to make an array of integers, student ID. And I'm just going to say that this can hold up to 20 students or 200 students, let's say. I don't have to use all of those, remember? I just use whatever I need. And then float grids. And because there are 200 students, there has to be 200. And this will be like their final grade, okay? Final grades. So I can ask the user to enter a student ID, enter a final grade for each one. And then I can see it. So first, let's do it this way. For int x equals 0, x is less than, you can ask the user how many students to enter. How many students would you like to enter? Num students. Num students is going to be an integer. It's just a variable. And so in this for loop, I'm going to ask for two things. Enter the student's ID. I'm going to see into student ID, which is the name of my array, sub x. X is going to go from 0 to num students. So x. I do the same thing with their final grade. And oops, enter the student's final. The name of the array is, this backwards, capital, should be the second word. Final grade sub x. And so this is where I fill up my parallel arrays. Okay, parallel arrays are filled. And let's go ahead and run it. Make sure that it runs okay. And then we'll output. Let's see. So final grades here, I forgot my semicolon. Student. So I misspelled because I can't type very well at certain times. Okay, so let's look down here. How many students would you like to enter? So I'm going to enter 4 students. I'm just going to make up some ID numbers. His grade is going to be 90. ID 87. ID blah, blah. And it stops. So I got 4. I got 1, 2, 3, 4 students. Now, if I want to see the data, remember there's 2 different ways that I can output this. I can do it with this kind of for loop or the shortcut. I'm gonna go ahead and do it with this for loop because I think it's easier at the beginning when you're learning how to use arrays to understand exactly what's going on. Like it's exactly going into the first element, the second element. So I'm just going to copy this, paste it, and instead of doing a cin, right, of this, I'm going to c out. So I'm going to say student ID and it outputs the student ID number. And I think I'm going to do it right next to it. I'm going to put the final grade of that student. So I'm going to put this right next to it. Like right there. Space. Final grade. So this will print the word student ID colon space, then his ID number, and then a space, the words final grade colon, then a space, and then the actual final grade. And then after each one, we want to add a new line. So we're going to do end L. Okay, this should work. I'm going to go ahead and take these curly braces. I could leave them on there, but they're not necessary. And I want to show that I know what I'm doing. So I'm going to take them out. Okay. Run. Just going to enter 3 students. So it says student ID 1234. Here's 1234, final grade 77. Student ID 3456, final grade 90, so on and so forth. And so my loop is getting stopped by this number, depending on how many students I want to enter. So those are our parallel arrays. The last thing I do want to cover with you is how to pass an array to a function. Okay, so we're going to go back to here. So I have this array called student ID, and I have the array called final grades. The thing to remember is that student ID, here, let me draw it over here. Okay, here we go. Get my pen out. So that array calls student ID, right? Student. I did not spell student correctly. Forgot the D. Student ID. Okay, so I have student ID. Student ID by itself without a subscript 0, 1, 2 holds, if you remember from my previous lesson, it holds the address of where this array starts in memory. So remember, this is like our student ID array, right? It has a bunch of different memory locations that are one next to another. So if I create an array of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements. So this is 10 elements. Student ID, let's say, has an address that starts at HXE0. So this is student ID sub 0. What I'm doing is I'm taking how much ever, if these are integers, let's say that they're 2 bytes, each of these are 2 bytes. I'm taking the 2 bytes and I'm saying 2 bytes. I'm at 0, so multiply times 0 is 0. I mean, not multiply times 0, add 0. So 2 bytes plus 0 I'm sorry, let me start over. 2 bytes times 0 will get me to this first spot right here, because this is 2 bytes. So to get me to the next spot, this is sub 1, right? So this would be 2 bytes plus 2 bytes. So now I'm going to be at HXE 4 or 2 actually, because it starts at 2. So multiplying times 1. So it starts here at sub 2. And this one will start at the next. So it multiplies. So we're multiplying 2 because the integer, we'll say that this integer is 2 bytes long. And we're going to multiply it times the subscript. But what's inside student ID itself is just the address of where the array starts. So student ID by itself without anything points to here. It points to the first element. What that means is that when you pass an array, you just pass the name of it. You don't pass the brackets. You define it in your prototypes with the brackets like this, but when you pass it, you just pass the name of it. So this is the prototype. This goes above before main. This is the header. This is where you like define, you know, your function, and you say like all the stuff that this function is going to do. This is passing it. You're just passing the address to the first element. That's all you have to do. When this says, when passing an array to a function, it is common to pass array size so that function knows how many elements to process. So you pass it the array, and you pass it the size of the array. Here's an example. Array size 8, numbers. So this is the name of numbers is the name of the array. This is the function prototype. It says, okay, I'm going to be passing an array and just a plain integer. Here's array, the integer. Where's the actual, oh, here it is, sorry. So numbers is the name of the array, and you don't have any brackets when you pass it. And then it's just the array size. This is just 8. So this here is a hexadecimal number. I'm just going to call it XHXF2. Let's say, for example, this address gets passed to here. And then now we're able to access, we go to that address and we're able to access our array. So we're not creating a whole new array. You're just passing an address to the array. Array names in functions are like reference variables. Changes made to array in a function are reflected in actual array. So this is just like a reference variable, and it's not a value parameter. Need to exercise caution that array is not inadvertently changed by a function. So it's always passed, we always pass arrays by reference because we're passing the address to it. And the last section is on 2-dimensional arrays, and I'll have a separate video for 2-dimensional arrays.